So here we have table of contents of today's video. So hope you enjoyed it. Here we have our main architecture, the main flowcharts, what we are going to be provisioning, what we are going to be deploying, all our resources, all our namespaces. Enjoy. Yes, and then again, it's just processing it and running the script, analyzing the logs, and this is the actual output also right over here. I also print, by the way, the output. Hello. Welcome everybody to this recording. I'm recording a video for my channel, Paulie DevOps. I have myself 7 years of experience in tech. The most of the years I have spent as a site reliability engineer. I'm greeting you with my fedora hat. Hope you don't mind. I just got it from one Red Hat event. Anyway, what project do we have for today? Ladies and gentlemen, today I would like to present you my project that is targeted towards SRE, DevOps, cloud, and platform engineering community. This is extremely comprehensive project that is touching a lot of different parts of modern infrastructure, scalable infrastructure. We are going to be showcasing infrastructure as code with Terraform, Kubernetes deployments, monitoring setup with Prometheus Grafana, and AI-powered incident response using AWS Bedrock with Claude Sonnet 4. We have a full-fledged interactive demo prepared that is going to be simulating a memory leak, a real incident-like scenarios. We are going to be capturing the logs, and then with the usage of AI, we are going to be analyzing the logs. We will, of course, remediate the incident, solve the incident, and apply preemptive measures so an incident like that does not happen in the future, following all of the best practices. If you want to know more about how to build a resilient system, I highly suggest that you follow something called AWS Well-Architected Framework and their 6 pillars. And you especially focus on the pillar for stability and performance. This is the timeline for the video that we are going to be looking into today. We are having the introduction. I'm going over the prerequisites and what packages I have installed on my machine. We are going over the architecture and what we are building, and then we will get right into Terraform deployment. We are going to be building an image with Docker, and we are going to be pushing this image into ECR, Elastic Container Registry in AWS. And we are doing a deployment with Helm and Kubernetes. And we are also deploying a monitoring namespace with Prometheus, Grafana, and some nice dashboards that are going to be monitoring our resources. After that, we are doing an incident simulation, and then we are having an AI analysis. This is a good one, guys, and I have spent a couple of hours trying to make this work. So there were some technical challenges. A little bit talk about the cost management and takeaway and next steps. Fine. What I want to say before we start, I have spent approximately 25 hours on creating this project. If you don't mind, please just consider either subscribing to the channel or following me down below on my LinkedIn profile. Would highly appreciate it. I'm posting stuff cloud SRE platform engineering related, so hope you enjoyed it. Let's just jump right into it. This is the table of contents. This is the project that you can see right over here, and I'm making all of this good stuff is going to be in a public repository. The structure, very briefly, we are having some GitHub Actions. I have automated some stuff with CI/CD, so we are having some jobs where we just click the button and it's going to be doing some stuff. So we are having some jobs or called workflows in GitHub Actions as my repository is hosted in GitHub. We are having an application that is going to be used for our incident demo. What this application is doing, that it has a couple of endpoints, memory status, memory leak. This is going to be an important endpoint that we are going to be calling later down the line during our incident demo. But basically, we have here dependencies that are important for our server application. But we are basically going to be packaging this application that you can see right over here into a Docker image. And then we are going to be pushing it into the ECR, Elastic Container Registry. And then we are going to be deploying this application into our Kubernetes EKS namespace. And we are going to be using it to simulate the incident. And how are we going to simulate an incident? We are going to be calling this memory leak endpoint, which is going to be, what you can see, every 3 seconds, it's going to be increasing the memory usage by 50 megabytes, which would cause at the end the container to crash, right? And then if it happens in real production, this would actually result in user transactions being lost and stuff like that. Anyway, then we are having Bedrock analysis. We will go over this a little bit later with some real examples. Flowchart export, there is nothing actually there. We are having our Helm charts, all of our resources, our deployment, our horizontal pod autoscaler, and a service account. If you don't know anything, or if you don't know some particular stuff about the topics that I'm going to be discussing, please just use ChatGPT 5, Claude. Just take the text and ask, what does it mean? How do we get this information, or how do you actually implement this? Just be a little bit curious. I cannot go over all of the details, guys, but feel free just to use AI in order to give you some details how this actually works. But long story short, we are using these Helm charts, and what you can see here, that here are some values, and these values are then coming from our values.yaml. This is a typical configuration where you would be deploying to different namespaces. You will be having a namespace for your dev environment, then an environment for your staging, and a production environment, and you might need to have different properties for each of the Kubernetes namespace, each of the environment. And for this, you might be using Helm or Customize. Then there is a short document about how the HPA is working. Horizontal pod autoscaler. We are going to be using this, and this is going to be one of our preemptive measure to solving our problem, but we will going to be talking about this one a little bit later in the video. We are having a Lambda project. I tried to use Lambda in order to analyze logs using AI. However, I did not make it work because I have encountered some incompatibility issue between a Boto3 Python package and AWS Bedrock. So I did not make it work, but you need to have Python installed on your machine in order for the deployment to go through. Don't worry, I have made this as easy as possible for you to follow along. Trust me, and I will explain it. So for now, just listen so you know at least what's going on. Monitoring Prometheus values. Prometheus, so we are having some Prometheus configuration. That's fine. Yes, we are going to be deploying Prometheus. We are having a lot of scripts here in the scripts folder, and we are going to be using some of these scripts manually. The most important ones are analyze incident with Bedrock. This is actually the API call that we are going to be doing with our log to analyze the incident. Then build and push. This would be actually building our incident Node.js application and pushing it to the ECR registry. Build would be building this Lambda. We will need to build it because it's included in my script, but don't worry about it. This is the main script that we are going to be using, deploy.sh. And you're going to be seeing a lot of crazy stuff with this one. This is actually a heavy script, and this is the main script for the video. Just deploy.sh. It's going to be doing a bunch of stuff, and I'm going to be commenting along. But just so you know, it's going to be mainly building our Terraform infrastructure. And then if you are done using or working on the project, please, you must run teardown.sh. This will destroy all of your infrastructure. So you are not paying money for your infrastructure because AWS is going to be billing. If you deploy all of this infrastructure and you keep it running, let's say for 3-4 hours, you can expect approximately $3 to $4 in billing. Not that bad. So don't worry, this is not going to break you. But remember to tear down the infrastructure with teardown.sh, and then you can verify that the teardown has been successful with teardown-verify.sh. So we would run deploy.sh. Then we are having one more important script, incident-demo.sh. This is an interruptive incident demo that we are going to be running. And then after you are done with everything, we are going to be running teardown.sh to tear down our infrastructure completely. Delete buckets, delete VPC, delete private subnets, delete public subnets, delete everything. And also our EC2s and etc. And then you can run teardown-verify.sh to verify that you actually destroyed everything. Good. Here we are having our main Terraform infrastructure. We are using something called infrastructure as a code because nowadays you're not going, for the learning purposes, you would be going into AWS. AWS, like here, I will talk about. You could go into EC2. I am logged in my AWS console. If you're not registered, please register. I'm not going over that. That's too basic. But what you can see is that I could go into instances and I could create an instance. Then you could specify what are going to be the properties, what image are you going to be using. Are you going to be using macOS, Ubuntu, Windows, or a Red Hat image, etc. But we are not going over that. What we are doing is that we are using infrastructure as code, and we are going to be deploying a bunch of stuff, a bunch of resources by running Terraform. The good thing about running Terraform is that you can have everything in the code. And once I ran this script, this Terraform, there is going to be a file created called .tf state file. This is going to be containing the state of our cloud, what resources have been provisioned. So it will remember what you actually provisioned. And if you will change something, that I will change this, I will change, I don't know, the version of the VPC to be 1, and I will run plan, it will actually see that you have changed something and it will try to redeploy only the change. So Terraform, an amazing tool. Please, if you are not aware or you're not familiar, spend some time, learn the Terraform. We are having some outputs. I'm not going over the details, and we are having some variables that we are going to be using. If you don't understand any stuff of this, please, what you can do, just Control-A, Control-C, put it into ChatGPT, ask it, what do we actually do here? What does he do? Okay? Just use ChatGPT, ask it, explain it simply, learn. This is extremely advanced project. And I'm not going all of the details, guys. .env, there is actually nothing important here, and we are not going to be showing it, obviously, because I'm having some API key here, but it is not needed for you to follow along, and I was just thinking that it will be needed, but it's not needed. Obviously, you can see that it's not included in Git because you are not pushing your secrets to Git. Spoiler alert. Anyway, the architecture. We need to go over the architecture, gentlemen. Maybe I should have shown it a little bit earlier, but this is the main architecture of the project. So let's start. We are going to be having a GitHub repo. This is the public repository that you're going to be having access to, and the repository is this one. I will maybe make it public for the audience. Here, what we have set up is that we are having some GitHub Actions, and we are having 4 jobs or workflows here. The ones that is actually usable is analyze S3 logs with Bedrock and build, push, and deploy application. These 2 workflows are actually usable. In order for these GitHub workflows to make it work, what you need to do is that you need to go to settings of your repository. Then you will need to go to secrets and variables, actions, and you will actually need to, it's hidden, but you see you need to set up these 2 secrets in your GitHub repository. So then the GitHub Actions actually do have access to these environmental variables. The reason why you need this, you would need to just do manage environment secrets, then edit AWS access key ID, and you would insert the password, and then AWS secret access key, and then you would insert the code or the key. Why you will need this is that our GitHub Actions are having AWS CLI installed on them, and we are going to be using AWS CLI to perform some actions in the cloud. Okay. If you don't know how to create the AWS access key and secret key, what you would basically do is that you would go to IAM. I will just briefly mention it. We are not going to be going over it. You would need to have a user. Mine is called master admin, and here security credentials most likely, and you would just create security credentials, and then it gives you the access key and the password key, or what was that one called. So you could create it here, and then you will have your credentials that you can verify yourself in order to get access to your AWS account. Okay. Good. So we have a GitHub repo. We have configured our GitHub secrets, and we are having some GitHub actions. Our local machine, local development setup. This is my computer that I'm working on right now. You will need a bunch of dependencies. We will go over it in a second. But we are going to be, this is sort of as a puppeteer. We are using our local machine to do a lot of these processes. I automated only some of it using GitHub Actions. In the real world, you would be automating more of the stuff with GitHub Actions, so anyone can come, click a button, and you do a full deployment, etc. But I'm not doing it for this project. That's not the scope. What you can see is that we are having CI/CD pipeline, GitHub, and we could be doing a Docker build, and then we could be also deploying stuff into our infrastructure. So on our local machine, we are going to be running Terraform apply. Terraform apply is going to be provisioning all of these resources that you can see. Maybe let me show it to you a little bit better. All of these resources. Let me put myself there. We are going to be provisioning our VPC. VPC is just sort of your network block where all of your resources are going to be living in. So you have a specific network block where you can be specifying network rules and etc. Who can access, how the inbound and outbound traffic can go. But this is all going to be provisioned just by running deploy.sh. All of it. We are going to be creating a VPC. VPC is creating a private subnets and a public subnets. Just very briefly, private subnets is sort of your mini network where you're going to be putting all of your resources that in general should be a little bit more in the backend. And the public subnets is going to be for your resources that should be a little bit more in the front. Meaning public subnet could be for your EC2 instance that is going to be having your front end, and private subnet would be for your backend EC2 instance where you are hosting, where you deployed your backend. Public subnet is hosting application load balancer. When the traffic comes to our cloud, we are using load balancer to distribute the traffic. And then the traffic gets distributed to our actual pods. We have here an EKS cluster, and EKS cluster is going to be managing our worker nodes. The worker nodes are actually just Ubuntu EC2 instances. Okay? And they are going to be placed in our private subnet. Then what you can see here is that on these worker nodes, we are going to be deploying with Helm our application and a bunch of resources. You can see here the application pods, and then the load balancer, when the traffic will come, it will be redirecting the traffic into these pods that are hosted on these worker nodes, which are just EC2 instances under the hood. And these EC2 instances are going to be managed by EKS cluster. If you don't know some of this stuff, please, again, Google it, ChatGPT, you have the tools nowadays, etc. Anyway, so this is our application layer. What you can see here is that you will be having a resource called deployment. Deployment is going to be managing your pods and how many replicas of the pods you're going to be having. You're going to be having something called service for routing the traffic. And you will be having some ingress rule for the network, and you're going to be having HPA, which is a horizontal pod autoscaler. HPA is going to be playing a really important part in our demo, in our project, because HPA is going to be how HPA works. I will show it to you later, but how HPA works is that we set a threshold for memory to be 70%. And if all of your pods, the usage of all of your pods will reach 70%, let's say that you are having 3 pods and HPA has maximum of 6 pods, HPA will deploy more pods automatically to handle the incoming traffic automatically. And then when you will have, let's say, the usage of all of your memory below 70%, let's say it's 30%, HPA will scale down the pods to its minimum state possible to based on your conditions. So you're saving resources and you're just not running 10 pods all the time during the night when you don't actually need those 10 pods. You maybe need 1 pod during the night or 2 pods. Anyway, we are then having our Prometheus, Grafana, and Alert Manager. Prometheus is going to be scraping our pods for some metrics. This is a topic on itself, how the Prometheus and Grafana works. So you will need to research it. Don't worry about it. It will be all working out of the box for you, but just know that Prometheus is sort of getting the metrics from the pods, and Grafana is visualizing the metrics and showing it in nice dashboards. Then you can be having an alert manager where you can be specifying alert rules. For example, if a memory of a pod will reach 90%, send an alert via mail, a notification in Teams, in Slack, and whatnot. Or it can be in a real world scenario. What will happen is that alert manager would be sending the alert signal to your ticketing system, for example, ServiceNow. Anyway, the actual incident will happen. Let's say that our application would be crashing and the memory would be reaching 90%, and then the pod just crashed. Because if you don't know what is a memory leak is a type of incident where your pod is using memory, but it's not releasing it back to the circle. Okay, so it keeps accumulating more and more memory. And let's say that we have a limit for our pod 2 gigabytes of memory, but your pod is having a memory leak, so it's going to be accumulating more and more memory. And what happens once it reaches 2 gigabytes, which is our limit, Kubernetes controller will actually kill your pod with OOM, out of memory error. Okay? And then hopefully you're having some logging system like OpenSearch or ELK stack, where you are saving these logs from the pods on some data node, so you can later see what's going on. We are going to be saving the logs from our application pod, and we are going to be running a Bedrock analysis of these logs, and we will use AI to analyze our logs and tell us what has happened, why it has happened, and how can we implement a preemptive measure so it doesn't happen again. Okay. In the old days, you would need to go through a bunch of logs, tons and tons and tons of logs. Now, with AI, some organizations are going to be automating it a little bit more with AI, the analysis in the logs. In my opinion, it's going to make the job much smarter. And you can use Bedrock for this. A quick comment: why Bedrock and why not SageMaker? if you go to our AWS, you can see Amazon Bedrock and Amazon SageMaker. With Amazon SageMaker, you can deploy your own model. Let's say, for example, I don't know, Claude or something, but you're going to be paying, it's going to be running as a, as I understand it, as a container in your EC2, and it's going to be running, you're going to be paying for the uptime. And it requires quite a lot of resources. So it might be a little bit expensive. But with Amazon Bedrock, it's purely working as a Lambda, meaning you send it your query, we send it our logs, it analyzes our logs, it sends us response back, what it analyzed, and you just pay for that call, literally just for that call. You are not paying for having all of these resources being allocated to your instance, like with SageMaker. So Amazon Bedrock is much cheaper, to my understanding. But feel free to Google and research more differences about these two. Anyway, so we are going to be analyzing it. We are going to be having two ways of analyzing our. We are going to be having two ways of analyzing our logs. We are going to be using some local analysis, and we are going to be using analysis by a GitHub action workflow that I created for this. So we have a GitHub AI workflow, ladies and gentlemen, that is ready and working and will analyze the log that we will place in S3 bucket. S3 bucket is a storage where you can store images, videos, log files, whatever you want. It's just, imagine it's like a USB or HDD hard drive. Goodie. So this is the main architecture, as you can see here. The Lambda, we are not going to be using Lambda so much. You can see AWS Bedrock, we are going to be using this one so much. CloudWatch. CloudWatch is a monitoring tool integrated into AWS, a native tool that is going to be monitoring your resources, like EC2s, EC2s, RDS. RDS is a database if you had one. We are not deploying a database in our scenario. We don't need it, and that's not the scope of this video. Otherwise, I would not spend 30 hours on this project, but I would spend, I don't know how many hours. So far at the moment, I am at maybe something between 25 and 30 hours, let's say, maybe 30 hours on this project. And our ECR registry, we are going to be pushing our images. Good. What do we have here? Architecture flowcharts. By the way, in order to interpret that MD file into something visual, you press Ctrl-Shift-V. So like this, Ctrl-Shift-V, as you can see here. Okay. And yeah, I'm using some mermaid blocks. That's here you can see how you can insert mermaid. That's fine. And here you can see our main architecture that I just showed you. Then we are having infrastructure provisioning workflows. We are going to be running Terraform, and it's going to deploy all of these resources. And then we are going to be using Helm charts in order to create our namespaces. Okay. Our CI/CD pipeline workflow, we are taking a source code and we have configured AWS credentials, and we are being able to do a Docker build, tag it, tag the image, and push the image to our ECR registry. Then with another workflow, we can then take this image that we have placed here, and we will deploy it to our EKS, Elastic Kubernetes Service. Application deployment. So you're having your worker nodes, you're having application pods, your health charts, deployment. This is our Docker application that we are going, Node.js application, which is going to be used in our incident demo. And it's going to be using the Docker file, and we are going to be creating a Docker image out of it. We are going to be putting it in ECR, as I mentioned. Good. Monitoring workflow and observability flow. Yeah, you can kube state metrics. We need a lot of this stack, kube state metrics, information about our pods, a node exporter, information about our worker nodes, about our EC2 instances, like how much memory and how much CPU they are going to be using. This is a lot of on different layers, guys. What you need to understand is that we have elastic Kubernetes. Then you are having your worker nodes, which are EC2 instances servers. And on these servers, we are then deploying the pods. This is all different layers that you need to understand. And we are having our application pods, which are going to be having our application metrics. And then we are going to be having our application logs. And then we are going to be visualizing all of this using Grafana. And you can be alerting on it using alert rules with Alert Manager. It's also going to be deployed. AWS Bedrock, you have your AWS account. You will need to enable a Bedrock access. How you can enable Bedrock access is that you would go to your Amazon Bedrock, and it will give you some intro guide or something. I don't remember. I think you actually don't need to generate an API key. I have done it, but you actually don't need. But what you will need to do, gentlemen, is that you will need to go to, which one was it? You need to do this manually. You cannot. Was it agents? No, it was not agent. Custom models. Agents. Cross region. Oh, important thing. AWS Bedrock is not available in Frankfurt. So what you will need to do is that you will need to change your region to North Carolina. Very, very important. Extremely important. AWS Bedrock, I repeat, is not available in European regions at the moment. On 8th of August 2025, you need to go to North Carolina. Wait. Actually, the North California? Hold on. North Carolina. So this one, settings, providers. Yes, you can be chatting with your Amazon Bedrock, but model access. Okay, here we go. This is what you need to enable. So I'm using North California, sorry. And we are using the region US West 1. What you can see here is that we are having Nova Pro enabled, Nova Lite, and Claude Sonnet 4. For our project, we are going to be using Claude Sonnet 4. Okay. And you need to have this one approved. You just need to say agree, and request access. Like, for example, there are some llama here, but I did not request for it. So you would just request access, and you need to have the access granted. Okay. So yes, we are going to be using Sonnet 4, except EULA, so some European licensing, and you can be doing then API calls. Incident response, we are going to be running our incident-demo.sh, and then we are simulating a memory leak. I'm not doing this too. There are endpoints in the application that I implemented, but I did not focus on that. It was actually too much work already with just memory leak and this all simulation and making sure it's visual for you guys. So we are going to be simulating just memory leak. If you want, you can be testing some stuff with CPU stress. There is an endpoint in the application that you can call for that. Then application logs, and we are going to be using these application logs in order to we are going to be then storing these logs of the failing pod into an S3 bucket and upload them in S3 bucket, and then we are going to be using AWS Bedrock with Claude 4 to analyze our logs. And we are going to be having immediate fixes, root cause analysis, preventive measures, what are the lessons we learn along the way, etc. Data flow, user developer, we are having GitHub repository and local machine. Then you're running your Terraform, creating your infrastructure in AWS, provisioning EKS with Docker that is with Docker Terraform apply with Docker build. You're having your Docker, ECR, registry, Kubernetes application, and you're deploying your application. You're having your monitoring layer. You're having your AI layer. Local analysis. Yes, there will be two different ways how we are going to be analyzing the logs using AI. One is going to be having our logs stored in TMP folder, and then we use our analyze script in order to analyze our logs. And we are going to be calling AWS Bedrock, which is going to be giving us the results of the analysis. And then we can be pushing incident-demo.sh is going to be pushing the logs into S3 bucket. And then we can use a GitHub workflow in order to get the logs from S3 bucket. It's going to be authenticating itself with GitHub secrets that you have hopefully configured. If not, I mentioned it earlier in the video, but you need GitHub secrets configured for your repository. The access key and the secret key. Good. Yeah. Key components, yada, yada, yada. Good. Let me check. I think we can start with the main presentation. We have the architecture done. So now we are actually going to the main presentation, guys. Hopefully you will enjoy it. We are already 43 minutes in and we haven't done anything. Damn it. That's how it goes sometimes. Anyway, ladies and gentlemen, this is the main presentation that you can see here, YouTube presentation guide. These are all dependencies that I have installed on my machine and that I have at the moment of this recording, and it does work for me. Everything does work out of the box for me. Okay, these are all of the packages, all of the dependencies: Git, AWS CLI, Terraform, kubectl, Helm, Docker, Python, pip. If you don't know what some of these are, Google it. That's how it goes. IAM policies. I know that there would be a question about this, so I am including all of it here, so you have it. I am having administrator access, but in the real world, you would be applying the minimum required access strategy, meaning that you would be getting only access to the resources that you actually need. But for me, I just approve anything. I can be bothered for the demo, so I just approve everything, and I specifically have some other policies that I edit when it comes to the SageMaker and AWS Bedrock, and you have them all pasted here. How does it work? you would go to IAM. You would go to IAM. You would have your user here. If you don't have create user, you would need to have your credentials, etc. And these are all the policies that I'm having. So they give me the rights to do some certain stuff. This one, Amazon Bedrock full access. This one, I have pasted them for you in the. I've pasted them for you in the YouTube presentation, and this one. This one. So these are my IAM rights. So you need all of them. So make sure you apply it. Anyway, what are the minimum requirements? Let's get into it. I will briefly go in over it. We will not spend so much time. You need to check that you have a Python installed. Just a second. Before we go, before we make something really clear. What you can see here is that I'm using a bash ls. So I am using something called VSL, a Windows subsystem for Linux. And you can actually install it by running these commands in your PowerShell as an administrator, and you can install a Windows subsystem. The advantage of having the Windows subsystem is that you can be using all of the Linux commands. And if you're working in DevOps, platform engineering, SRE, or cloud, you must know Linux. No question asked. Okay? So even if you are using a Windows machine, I'm still running Linux subsystem. So you need to have a Linux installed. If you don't know what is a VSL, Google it, learn about it, etc. So anyway, you can follow along even on the Windows machine or on a Mac machine, but on a Mac it might be mostly compatible, but on Windows you will need to figure out how to install all of these dependencies, probably using Chocolatey package manager, ClaudeAI, or some other stuff. Anyway, you need a Python, so you would be running sudo apt install. You would be installing the Python. This is how you would do it with the macOS. You would be running it on brew. You would be running a pip. Pip is a package manager for Python, so you would need to install pip. Make sure that it is installed, and you can verify with these commands. We are not running this yet. We are going over the requirements. This is our main deployment script that we are going to be running soon. Then, obviously, you will need Git. Make sure you install Git. Critical AWS budget. I can briefly go over that. But basically, you have your account here, and you go into billing and cost management. And you can see I spent $20, and I spent it in like 2 days, kinda. 3 days maybe. But anyway, what you need to do, guys, is that you will need to go to budgets, and you will click create budget, and you will select the budget, and you will select amount use. Hey Google, bedroom on. Okay. You will select your budget, and you will select, I set my monthly limit to be $50, just so you avoid some unexpected cost. Please set your budget. That is the best practice. Okay. Let's go back to our requirements. We hide this one like this. You will need to install AWS CLI. Make sure that you install it. And then you need to run AWS configure, and you need to insert your AWS access key and secret key. This is the same credentials that you would be using in your secrets, in your secrets and variables action. So those are the same values that you are creating in your IAM, your secret keys for your user. Okay, so you need to configure that. If you don't know how to do it, Google it. That's fine. You need to install Terraform. Terraform is going to be building all of our infrastructure, so you need to install it. Okay, you have some instructions here, etc. kubectl is going to be needed in order for us to manipulate with our Kubernetes cluster. So extremely important package. Okay. Install Helm. Helm is going to be using for us to be running our Helm charts in order to be deploying our application. Yeah. Then Docker. You need to install Docker locally on your machine, so you are able to build our Node.js application and create an image from it. We are using a Docker file in order to create an image. Okay. Then a verification. What you can see here are prerequisites. I will just run it so you can see how it looks like. You know what? Let me just run all of this stuff. Control C. Paste. Yeah, what you can see here. You see my Git version. The Helm version. Did it run? Something happened maybe. Yeah, my Helm version, Terraform version, and AWS version, Docker version, kubectl version. Everything must be working for you guys. Okay, so you can follow along. You need, this is the most important. You need to have these packages. You need to have everything running. Yeah, we can run Docker PS. I think that's okay. So probably we are running no images, so that's why it's Docker PS doesn't work, but it doesn't matter. Anyway. Project architectural overview. Yes, I mentioned VPS, EKS, IAM roles, networking. We are creating our Node.js application that is going to be, we are going to be calling the memory leak endpoint, which is going to be increasing the memory usage of that application till it crashes. Deploying our namespace, etc. Good. We are not deploying yet. I need to explain to you guys something. But to make it simply, we are going to be just running this script to deploy our Terraform infrastructure, build a Docker image, push a Docker image, deploying our Kubernetes namespace, do a deployment of this image that we are creating, and deploying our monitoring stack, which is Prometheus, Grafana, and Alert Manager. And all of this is going to be achieved by deploy.sh. Okay. This is manual step by step, and I will go over it. So what we are doing is that we are going to be git cloning it. You would need to git clone our repository, and then you would be going into our Terraform directory, so cd Terraform, you will be inside this, and you would run Terraform init. This is initializing the project, okay? And it downloads the required Terraform providers and modules in order for it to actually deploy our EKS, etc. Main TF variables, TF output. This creates our VPC EKS cluster and IAM roles. The IAM roles are not for our user, but it's actually for the EKS. So the EKS itself, it's allowed to create worker nodes, which is allowed to create the EC2 instances. You can then run Terraform plan. This is going to show you what resources is it expecting to build. It says I'm expecting to build these EC2 instances, this Kubernetes service, this VPC, these private subnets, public subnets, all of it. Okay. This is also automated in the deploy.sh, which is our main script, so you don't need to do it, but you will need to build the Lambda with Python, even though the Lambda does work, but it does not use S3 logs, it uses local logs. That doesn't matter. Terraform apply, this will start applying our infrastructure. Then you will need to configure your kubectl, and then here you would be doing a Docker build. You would be going into the app directory, which is this one. And here you can see we are having our Docker file. We are using Node 18 Alpine image from Docker Hub. This is a public base image. And then what we are doing here is that we are installing all of these dependencies and packaging it all as a container. So then you have an image and you can be deploying this from this image, how many pods you want, 10, 20, 30. And we are adding some other stuff and exposing everything on port 3000. Let me continue. Yeah, you will need to build your image. This is going to be all automated in deploy.sh. You can then analyze that script further if you want. Tag for ECR. Yes, you're going to be tagging your image for ECR and you're going to be pushing it. I'm having all of the resources placed in EU Central 1, which is a Frankfurt region. And we are then pushing the image to our ECR. I will show it later. Then we are going to be going into our Helm, this one, where we are going to be doing Helm upgrade install SRE demo app. We are setting some parameters, namespace default, and we are setting a timeout. But what this is going to do is that it's going to create a deployment. It will deploy all of these resources. The deployment where it's going to be taking our image that we will create, HPA, horizontal pod autoscaler, service, and service account. All of these ones are needed. So, but Helm is going to be doing it all for you. If you don't understand any of this part, again, just ChatGPT it and ask why does he do this. You might be asking about this Ninden4. There was some problem with some length of some Kubernetes properties, so I have made some workarounds. You can again ChatGPT this file, and what do they do? But that's out of the scope for this video. Monitoring setup. We are going to be installing EBS CSI driver. This is actually required because I was getting some errors when I did not include it, so I had to actually include it for you guys. And we are including our monitoring stack, Prometheus, etc. Then install Kubernetes dashboard. We are going to be having a Kubernetes dashboard so we can nicely visualize how many pods we are having, how many deployments we are having for specific services, specific namespaces. So this one, etc. Then you can access your Grafana. We are going to be having already deployed Grafana dashboards that we are going to be using. And we are going to be running kubectl proxy in order to run our Kubernetes dashboard. Then we are going to be simulating our incident demo, and we are going to be running this script for it, incident-demo.sh. Okay. Then AI powered analysis. After the incident demo, what it's going to do is that it will going to crash the application that we are having in EKS, and we are going to be storing the logs in S3, and then using AI, it's like this. Our incident demo is going to crash our application. We are storing the logs. We are going to then place the logs in two places. One place is going to be in our /tmp folder on our machine, on my computer. And the second place is going to be in S3 bucket for remote analysis and backup. And then we are then going to be having two ways how to analyze these logs. And I will show you both of them. You can be using this analyze incident bedrock.sh script, which is going to be analyzing, taking the logs from here, and then pushing, doing an API call to Amazon Bedrock using Claude Sonnet 4, and it's going to be sending the logs to Claude Sonnet, and Sonnet will send you the response with the analysis. The other way is that we are going to be using our GitHub workflow, which we will provide a link to the object URL to the log from our S3. We will give it, this is our log, GitHub action, please analyze it, and then again it's going to be calling AWS Bedrock Claude Sonnet 4. Show the workflow, etc. Local analysis, fast, no network, no local setup, shareable. So we are having two ways how to use AI in order to analyze our logs. And then I have a pretty good prompt that we are asking Claude in order to analyze our logs. I can show you the prompt later. Anyway, this is the flow. Incident demo, we are storing the logs locally on S3, and then we are doing AI analysis, and AI is going to be giving us the insights and solution. Then we are having some cleanup. For cleanup, you just simply run Terraform destroy within Terraform folder, or scripts teardown.sh. You can see Terraform destroy auto approve, like destroy everything. We want to destroy all of the infrastructure so we don't pay for it when we are not using it. After that, you can be running Terraform teardown verify sh, which is going to be checking, okay, you are not having any EC2s and any resources. This one doesn't matter. Cost management. If you would be running it the whole time, it could get pricier. As I mentioned, for like 3-4 hours, I think I paid like $4 or $5 or something like that. It's not going to break you, don't worry. But set the budget, please. Some comments, some service issues, how you can investigate, some load balancer issues, and what we've accomplished. Good. That .tf state file is going to be only local on our machine in a real world, what you would do is that you would place the tf state file into your S3 bucket, and then you would be managing the log using DynamoDB. So only one person at a time can be using the Terraform apply. No more, no. It with TF state mechanism with S3 bucket and DynamoDB log, you would make sure that only one person is provisioning the resources and not two people, because that would create problems. Feel free to research that, ask ChatGPT, and etc. Resolution, we are actually recording in 2K. And this is the video timeline summary. Yeah, we are now at 1 hour and we did not even start, and it's saying that we should be already done. That's actually funny. Anyway, we have application deployment. Okay. Now we are going to be doing the actual deployment of the infrastructure. We are now doing hands-on. Hands-on starts now. Okay? So follow along. Please follow along. This is the most important part, because now we are actually doing stuff instead of just yapping. Okay? Where we are in this directory on my VSL. You can see that I have my VSL Ubuntu connected. How you can access your VSL folders is that you would write this in your Windows //vsl.localhost, and then you could be having the path. You can see that if I would write home Pavel SRE Terraform, I would be ending up in this folder, which I could probably show. Just a second. Just a second. Yeah. So what you can see here, this is what I type into the path, and we are here where we are in our file explorer. But this is where we are going to be having our logs, so that's why I have it open. Anyway, to continue. Now we are actually going to be deploying our infrastructure. So what you need to, what we are going to be doing now is that we are having our scripts directory right over here. And we are going to be doing, have a look please, now pay attention. We are going to be doing /scripts. You need to be in the root of this repository. Very important, please. And here you're going to be F2, Control A, Control C, right click, and we are starting deploy.sh. Okay. Enter. What we are doing now, I'm going step by step. We are validating some stuff. We are validating our Helm charts. A lot of stuff is going to be done now. We are now running Terraform init. Where is Terraform folder? We are running Terraform init. It's downloading a lot of packages. Now this is running Terraform plan. It's planning to add all of these resources that you can see right over here. Create node groups, egress all, ingress cluster, security group, create a security group for our EKS. It's going to be, this is the plan what Terraform wants to deploy to our EKS, to our AWS account. All what you can see right over here. So this is all planned. All of these resources, all of this is going to be deployed. And now it actually started creating all of our resources. Remember, at the beginning of this demo, we had nothing in our AWS account. All I had was my user in IAM created. That's all what I had. So now what it's going to be doing is that it's creating NAT gateway, EKS cluster. It's creating all of the resources, what you can see here. Here it created that tf state file. This is extremely crucial file, and you should be not putting it in Git, because it gives basically the overview of all of your infrastructure. So the good practice is put it into S3 and manage it with the DynamoDB log. DynamoDB. If you're not sure how to do it or how it's done, you can Google it. But for the demo purpose, we are just having it locally here, and I have added into our git ignore. I have added in our git ignore, so we are actually not deploying it. You can see it's being ignored here. Good. So what we are doing now is that we are deploying all of our infrastructure. We can check how does it actually look like. In this is our AWS Bedrock. We have our budget, and EC2 instances, we are not having anything yet. It's going to be coming up soon. You see instances 0, Elastic Container Registry. I think this one has been created. No, not yet. Okay. Oh, it did create it. You can see we just created it now 2 minutes ago. So this is going to be our repository where we are going to be pushing our image. And it has created our VPC. And we can see all resources very nicely. Frankfurt, one VPC, 4 subnets, 3 route tables, 1 internet gateway. Internet gateway is how your resources actually get access to the internet. Okay. And Aurora and RDS, we are not having a database here in this project. S3 soon. Did it create it now? Oh yeah, it created the S3 bucket now. Okay. So let's just check what it is doing now. The provisioning of the EKS takes approximately 5 minutes. So it takes a while, to be honest with you. What you can see here, 3 minutes elapse. But we can just see. So this was running the Terraform plan, as I mentioned. It's showing all of the resources with plus that it planned to deploy. Oh, and then we cannot go even higher. But remember, all of this is being done just by running /scripts/deploy.sh. That's all what you have to do. And if you have all of these prerequisites, as I mentioned, all of these prerequisites, if you have all of these prerequisites, as I mentioned, you will be then flying right away. You can take off because it's going to be doing all of the stuff that it needs to do, but you need to have all of the IAM roles and policies required for you to do this stuff and provision those resources. And you will need all of these dependencies on your machine. And you will need to run all of this stuff on some Linux system, VSL, as I propose. Yeah, because we are actually running a lot of .sh scripts. So I think on Windows, it's not going to be working because we are really relying on a lot of bash scripting in this project. So you need to be running this either on Mac or an Ubuntu machine or a VSL if you're running it on Windows. So please be aware of that. We are having a lot of heavy bash scripting here. A lot of good bash scripting is happening. So what I want to visualize for you guys is that if we go now, we open EKS and we open EC2, we are again in Frankfurt region. Make sure that you are in the proper region. What you can see is that our EKS is now being created. Excellent. Created 6 minutes ago. It's still creating with the Kubernetes version 1.28. That's good. That's good. What will happen afterwards is that the worker node will be worker node group will be created, and we will see some instances pop up here that are going to be created. So it is still creating our AWS EKS cluster. I will just pause the video till it moves to the next part. Just a second. Okay, welcome back, guys. Actually, there was no break for you. I needed to get some water. But you can see the EKS is being created. As you can see right over here, it has 9 minutes has passed. Some security groups are being created. That's excellent. And yeah, it's still doing its thing. We will let it do its thing. What I will do here for you guys is that I will say YouTube bullet points.txt. In this file, I'm having my script for the video. But I'm actually I will maybe upload it later. That's not needed. Anyway, it's creating now EKS node group. Node group is you're having your EKS, and then you're having your EKS node group, which is going to be managing your EC2 instances, which are going to be your actual nodes. So your EC2 instances are going to be the nodes. But what we will need is that we need to create a node group in order to allow EKS to actually be managing this node group. So that's why we are creating the node group right now. Okay. After the node group will be done, let's actually check what is the status on our EKS cluster. Good. Our EKS is now ready. Our bucket was created. Our VPC resources were created with all of the route tables, the net gateways, the VPC, and the subnets. That's good. And now it's creating the worker node group. That's good. To cluster endpoint, yada yada yada. Now it's doing setting up Kubernetes infrastructure deployed successfully. Good. Now it's setting up some secrets and some role bindings inside our Kubernetes cluster. Oh, and we can see that there is a first error. Building Docker image cannot connect to the Docker daemon. Okay, that's fine. Okay, what I have done, guys, is that I have just gone into my Windows and I have started my Docker desktop. Okay, I did not have it running, so I started my Docker desktop. Good. What I wanted to show you is that we can have our EKS. And what you can see here is that resources, compute, we have our node group being created. And note, it doesn't show there, but let me check the EC2 instances. We are having our EC2 instances right over here that are being created with T3 medium, and these are going to be the actual nodes where our pods are going to be deployed on. And I have chosen two different availability zones. The region is still EU Central, but you can be having different availability zones in order to increase the resilience of your system, right? If one availability zone has gone down because there is a flood, there is a tornado, the data center is down, then you would be having your other availability zone still available. So you're avoiding some infrastructure problem with the electricity, or as I mentioned, flood or something. So it's good to be spread across more availability zones in order to diversify the risk, right? Or someone might be the data center, they might unplug a cable, suddenly everything is down or something. So that's good. So we have started running our the Docker desktop. The good thing about this Docker this script that we are running is that if you will see an error, like the error happened here, you don't need to panic. I have built the script so it will, you can be rerunning as many times as you want. It knows what you have done and it will respect it. So it knows we have created the VPC and EKS and EC2 instances and everything. So don't worry, please. So we are going to be just rerunning it just like this. But one thing that I wanted to show you would be EKS. There should be also an auto scaling compute desired state is 2 T3 medium. There's nothing shown here. Okay, we continue. Guys, what I wanted to show you, if I go into my cluster, we go into, where was it now? The node group, you will see something called auto scaling group name. We will click this, and this is our AWS auto scaling for our work nodes. And what you can see here is that we are having two availability zones, and we are having the desired capacity of 2, and the maximum is 3. So we are allowing maximum 3 worker nodes, 3 EC2 instances to be deployed if there would be not enough resources within these EC2 instances. Okay, so just so you know. And then of course these EC2 instances are having some volumes, volume and stuff like that, but we are not going too much into details. You can analyze the repository as much as you want, and feel free to discuss everything with Claude or with ChatGPT. So you learn. You need to learn because there is a lot of stuff. Anyway, as I mentioned, we are now going to be just rerunning our deploy.sh script because I did not have my Docker running. Now I have my Docker running. Deploy.sh, and what you will see now is that again it's doing some validation scripts and it's checking if this lambda was zipped. That's why you will need to have Python installed. It is checking if all of the infrastructure is deployed, and yes, all of the infrastructure is deployed successfully. It is just double checking if we are having some Kubernetes resources. Just a second, guys. Yes, ladies and gentlemen, we continue. Small interruption. What actually happened is that for some reason my Docker was not being able to connect to my VSL. So what I had to do is that I had to basically reinstall the Docker desktop on my Windows. So that's what I had to do. Anyway, we continue now. Uh, we have provisioned our AWS infrastructure, and then what we just do is that we rerun the deploy.sh. That's all what we do. We continue rerunning deploy.sh. So we are running the script, initialize the backend. It will be comparing the stuff with the tf state file, as we mentioned, and there is basically it's telling it that everything is provisioned. Applying, but I think everything is there. Setting up everything unchanged, some Kubernetes resources, not a problem. Good. Now we are building our Docker image. So you can see different layers of the Docker image being performed here, and this is all basically coming from the app here, where it's performing all of these different steps. It's putting in the image the package.json and the server.js. Then it's using this Node 18 Alpine base image, and then it's installing all of the dependencies in it. Then it pushed the image into ECR register, Elastic Container Registry, in AWS. I will show you that in a second. So our image is there. What we are doing now is that it is deploying this application using Helm, what you can see here. Oh, SRE demo does not accept. It's installing it now. And then it's installing something called EBS CSI driver. We need it for monitoring. So don't worry about it. It's not there. So we are installing it now. So it's installing it. That's good. Port EBS CSI controller. Good. So the CSI controller is ready. And now we are installing something called a metric server, so we can be getting our metrics. We need some RBAC policies. We need some cluster role bindings. We created a service. We created a deployment. These are going to be all resources in our monitoring namespace. But again, it's all happening under the hood with my deploy.sh script. You don't need to worry about it too much. Good. Now we are going to be deploying Prometheus and Grafana again in our monitoring namespace. I will show you all of it, how it looks like. But yeah, deploying Prometheus and Grafana. And in Helm, what you can see here is that that's deployment, but I think deployment. This is for our application. That's fine, but this is for HPS. Just a second. Promise configuration for Prometheus demo. This is going to be our Grafana password. The username is going to be admin, and the password is going to be admin123. And what these ones are going to be. Okay, so this is some dashboard, but we will have some dashboards already available in Grafana, so don't worry about it. So let's just wait till. Okay, good. The Prometheus and Grafana have been deployed. Oh, and we are done. Let me go back to it. Verifying deployment. Yes, we can see our our application, which is our server.js. This application have been deployed. It's called SRE demo app. You can see the targets here. These are the targets for horizontal pod autoscaler that we have also deployed. Here is a load balancer, deployment verified successfully. We are having also the application URL, so this application is also available publicly, but it's just a dummy application, so yeah, it's up. The application is working. Incident SRE demo app. This application is mostly just backend, so there is nothing like fancy buttons or anything. It's just purely these URLs, and then you could be doing some API calls, some memory leak, etc. So it's just a backend application that you can do API calls to. But what you can see now is that the deployment has been successful. So what we have done here is that we have deployed all of our Amazon resources. We have built this as a Docker image. We have deployed it in EKS. I will show it in a second. We have pushed this image into our registry, and we have deployed Prometheus and Grafana. Let me visualize it for you so you can see it. So we go back here. Autoscaling group, that's fine. Elastic Container Registry. So you can see it right over here. Wait. Yeah. So we have created it 1.5 hours ago. And the image, yeah, the image has been pushed 5 minutes ago. So it's this one with the tag latest. And this is the URI of our image. What we can do now, ladies and gentlemen, is that let me go back to our cursor IDE. Just a second. What we will do now is that we will visualize it for you very nicely. So we have built it. Good. Let's continue right over here. kubectl and Grafana shortcut. This has been all pre-configured, so don't worry about it. So what you will need to do now is that you will take this, and you will basically just paste it in your VSL terminal like this. And what this is going to do is that it's going to be forwarding the Grafana into our local host 3000. Okay. So we are just forwarding it to the port 3000. What it will do is that you will then be able to have your Grafana here. But this is actually the Grafana that is deployed in AWS. The password is admin. No, the username is admin and the password is admin123. Okay. So this is the username. This is the password. Got it. You log in. Don't worry about it. Yeah, we don't want to save it. And what you will see is that you will see a lot of very beautiful dashboards right away pre-configured for you, right over here, working out of the box. So all what we did so far is just ran from scripts deploy.sh from the base of the repository. That's all what we did. Run deploy.sh. Okay. What you are able to see now is that we are able to already be monitoring our resources. We are able to be monitoring the pods in our monitoring namespace. and the resources like CPU, memory, and etc. But let me visualize this a little bit better for you. At the moment, we will keep our default namespace, which is our incident demo application that you can see right over here. Good. Back to the editor. Back to the. Ooh. Good. What we will do now is that we will run this command, kubectl proxy. I'm clicking here in my cursor editor plus and right click kubectl proxy. Enter. Now it's being. Now we are having our dashboard, the Kubernetes overview dashboard, hosted on localhost 8001. What we will do now is that I will take all of this, Control C, it is this file, Control C, go back to the Google Chrome, Control V, and now it's asking us for the verification. But that's not a problem. What you will do now is that you will go back to our kubectl. We will open another Ubuntu terminal. And what you will need to do is that in the scripts here, you will need to run the script which is called get dashboard token.sh. So what we will do is scripts get dashboard token, and I hit tab for the autocomplete. Run it. Now it's generating our token for our Kubernetes dashboard. We will take it, right click, so it's copied. It's available. It's valid for 1 hour. And what we will go here is that we will go here, token, Control V, sign in. Good. So now we have a nice dashboard. I have a lot of experience with a Kubernetes framework called OpenShift 4, which is a Kubernetes framework from Red Hat, and they are using some similar dashboards like what you can see right over here. Anyway, we are having our namespaces here, and we are having our deployment. You can see that at the moment we are running this deployment is responsible for provisioning one pod, and then we are having the pod running here, and it's running on this node, which is our EC2 instance. Yes, and here you could see the logs, or what you could see is that you could go into the terminal and see how does it looks like. You see we are having our node modules, and we are having our package.json, which is package.json is this one, and server.js is just this node application, our incident demo application, where you can be calling some different endpoints like API data, API stress, API failure mode, and some others, and then it's going to be calling these different functions and functionalities. If you want to know more about this application, just take it, put it into ChatGPT, and ask it what does it do. Good. What you can see also is that we will go into a namespace called monitoring. And what you can see is that we are having 3 deployments. We are having our Prometheus Grafana, our Prometheus operator, and Kube state metrics. And we are running 5 pods, or actually maybe more. How many pods? We are having node exporter, that is, so node exporter. Node exporter is getting metrics from the EC2 instance, and Kube state metrics is getting the the metrics from the pod, like is pod restarting and is pod healthy. That is going to be crucial, these cube state metrics, for our incident demo, where we are going to be sabotaging our application. Then we are having our operator, and then we are having our alert manager, where you can be defining the alerts. And we are having our services. What you can see here is that our Prometheus Grafana is having an external endpoint. If I click here, then it's going to be basically the same Grafana as this one that I'm forwarding to my port 3000. So this is the same Grafana that is publicly available externally. Normally in the real world, you would be probably having your VPN. You would be connecting to your VPN, and then all of these resources, this Grafana, would be only available to you once you are connected to your VPN extra layer of security, because you are not going to be having resources like this publicly available. Like Grafana for Netflix, for example, is not going to be publicly available that you can just type URL and you're there. That's not gonna happen. Good, but it is the same one, admin and admin 123. And you're having the dashboard. So it's exactly the same Grafana. We are just having it locally. That's good. And so those are our resources. Here we go to our default namespace, and similarly, we are having that external endpoint for our demo incident application. Okay. Let me go back to my notes. Okay. Don't worry about this token. It will expire in 1 hour anyway, so it doesn't matter. And then after that, I will tear down the infrastructure anyway. We are now having something called horizontal pod autoscaler. This is a very important metrics in Kubernetes ecosystem, because what it does is that, as I have mentioned it at the beginning of the video, it is having a couple of properties. You're having the minimum pods, you're having the maximum pods, and how many replicas are running at the moment, and what is the age of the autoscaler. The targets are, I think the first one is memory, and the second one is CPU, as I remember, but I'm not 100% sure. We can check that later. But basically, how it works: if your application would be let's say that you're running 2 pods. No, let's say that you're running 1 pod, just for the simplicity. And if it's going to be reaching 80%, just a second. I think I created here I created a document for it just to explain it a little bit later, a little bit better. So the autoscaler is defined by here, and the values autoscaling minimum replicas are being inserted from our values.yaml. And autoscaling, what you can see here is minimum replicas, maximum replicas, target CPU utilization, and target memory utilization. What you can see here, let me go to the preview mode. This is the configuration for our HPA. And what you can see here is that the target memory utilization is 80%, and memory limit is 2 GB. This is a memory limit for our pod in our Kubernetes cluster. If our pod will reach 2 gigabytes, it will crash. So that is the incident that would actually happen. So what is actually the scaling behavior? As you can see here, when average memory across all pods is more than 80% of requests. Okay, so it's based on the requests. HPA creates new pod to distribute the load. If one pod uses 220 megabytes, HPA will scale up. Scale down. If the amount of resources is not going to be used, HPA will actually scale down the pods. Application memory leak, control via API calls. Here you have some scenario. This is a scenario that we are going to be going over in a moment, where I'm going to be running the incident demo. This is exactly what will happen. I am going to be activating memory leak endpoint on my application SRE demo. What will happen is that I think it's like 20 megabytes or 30 megabytes will be adding on the memory utilization of this pod, and they will be not releasing. So what you can see right over here is that the pod will go from 20 megabytes to 1 GB to 1.5 GB within 2 gigabytes limits. Result. In our case, what will happen is that when the pod is going up, it will actually just releases all of the memory. That's how the application is written. I will show it to you in a second. But in this scenario, basically what you need to do, that as HPA is going to be scaling the pods based on the loads, based on the threshold across all of the pods, and for our demo we are actually going to be disabling the HPA because we are going to be simulating the memory leak. So we don't want the HPA to actually be spinning up the pods for the purpose of our demo. We are going to disable HPA, run our demo, and then HPA would be sort of that would be a preemptive measure that you would have in the real world. Verification commands and etc. So this is what we will have. During the demo, we will disable the HPA. After the demo, we will be going back to normal. I think it's now time, gentlemen, to actually run our demo. Good. So you can see this is the nice dashboard, and you can have you're having all of your resources there. What we will do now, not to let you wait any longer, is that we are going to be running our incident demo. In scripts, what you can see is that there is this file, incident demo. Wait, what is this change? Yeah. I don't know about that. I guess no. Anyway, our incident demo. This is very interactive file that is going to be going through all of the demo simulation for us. So all what we are doing is that we are running the scripts incident-demo.sh. Okay. We will be visualizing what is going on in Grafana. So let me go. Are we in? Yes, you need to go in this one. Compute resources, namespace, pods. This one right over here. And you can see the memory usage right over here without cache. Okay. you can see the memory requests and the memory limits right over here. Good. So going back, we are now going to be running our incident demo, and maybe I can make this a little bit smaller. We can see the actual resources. We can see the graph, something like this will do. Okay, in terminal, we are now running our incident demo. So have a look, gentlemen, ladies and gentlemen. DVD. File in that directory. Just a second. Copy relative path. We are in the base, right? Okay. Just a second. Okay, back at it again. Quick debugging. The problem was that actually the script was having line ending M characters, and we had to actually do these do's to Unix code. And afterwards our incident demo is working. So let's have a look. Anyway, we make it a little bit smaller, and we are running it. This one, go lower, script incident demo. Oh wait, we need to go one level lower. Sorry for that. Good. We are now running our demo finally. So what you can see is that we are going to be showing the healthy state, the memory leak. We are going to be detecting and diagnosing the issues, and we are going to be providing resolution and recovery, and we are going to be doing verification, and afterwards we are going to be doing the AI analysis. What you can see now is that we are going to be logging all of this stuff into this file locally /tmp incident logs. Let me minimize it because we will need to see our Grafana. Somewhere like here. Good. We are starting the demo. Enter. So what is the pod status? We are having a healthy pod, calling a health endpoint. The application is healthy. That's good. We are using at the moment 23 megabytes resources, and we are capturing some logs, taking some logs, etc. We are disabling our horizontal pod autoscalers at the moment. Enter. Now we are calling our memory leak endpoint. The application will continually increase on the memory. Please be checking here. You can see at the moment it's 24 megabytes. Oh, now it's 1000 megabytes. Have a look, guys. 1000 megabytes. Meanwhile, it's checking some stuff. So 1000 megabytes. And ideally, we should also be able to see it on our Grafana. 1000 megabytes, and it returned back to 3 megabytes. And I think actually it might not be captured by the scrapes because it happened too fast. But what actually happened is that we have called our memory leak endpoint. The memory was raising 20 megabytes, 100 megabytes, etc. And it reached, before it reached the memory limit, it actually released all of the resources. In the real world, your pod would reach 2 gigabytes, which is our memory limit, and it will just crash with out of memory error, OOM. So what you can see is that once the resources were released, we can now see back to 20 megabytes. We are capturing the logs, and detection complete. We can see the memory leak affecting our application. Press enter. What you would do in this scenario, we will also run the AI analysis of the situation, but press enter. What would you do if you see that your application was reaching 80%? You would simply roll it out. So what you can see here is that we are going to pods for the my credentials have run out, but that's not a problem. You know what? Let me just generate quickly a new get dashboard token. We are going back to our demo just a second, guys. Sign out. Okay, paste it. Pods. Okay, we are having our pod here. But what you will do in such scenario is that you would actually do a new rollout, a new deployment, which is going to be scaling a new pod. Once that pod is ready, it will scale down the sick pod. Okay, checking the application, checking memory status, yada yada yada. So what we can see is that we are having at the moment our pod running. We are capturing the metrics, and we are enabling the HPA. HPA, we had to disable it at the beginning of the demo. When I ran the demo, there was actually one line disable HPA. Then we run the memory leak. Then what happened is that we have created a new we have created the memory leak was reaching the pod was reaching all the way to 2 gigabytes, and then it released all of its memory. And what we have done afterwards is that we have done a new rollout, a new deployment, which have created a new healthy pod and scaled down the sick pod. What you can see afterwards is that we have re-enabled the HPA, and the HPA is having 5 pods maximum, and for some reason it actually what it does is that it starts running 5 pods right away after I enabled the HPA. And I think it might be because we were having some bad logs with our resources and how the resources were utilized. So that's why I think that probably we are going crazy, because we were calling our memory leak endpoint, which was causing the application to be going mayhem. But we are not going to be using all of the resources. So what is going to happen is that I think it's within 5 minutes, if the resources are not going to be utilized, which are not, because we can see that at the moment all of the applications are using only 19 megabytes of the memory. What will happen is that the HPA will actually scale down all of the pods, and we will just end up with 1 pod. Now we are having our pods locally. Let me show you what happened, ladies and gentlemen. Let me show you what happened. So they are stored in /tmp. Okay, have a look. So we are having, I'm here, /vsl.localhost, Ubuntu tmp is the same like /tmp there. What you can see is that it created incident logs. So it was taking the logs from the Kubernetes, and it has created this log file right over here with the current date and the current time. So if I open it and I show it to you just in the text file, what you can see is that it's printing a bunch of stuff. It's printing the pod, the node, and a bunch of situation and snapshotting some stuff, metric snapshot, showing the healthy endpoint, etc. So this is our log. And in real world scenario, you would be always having the logs of your pods, so you can actually investigate what happened during an incident. You can see that on our graph, something has happened. At the moment, we are having these 5 new pods, but if the reason why we are not able to see on the graph that 1000 megabytes, it should be spiking much higher, it should be spiking all the way up here, was that we are scraping only every 30 seconds, and that memory hike happens so fast that we were actually not capturing it in our scrapes because we are only scraping every 30 seconds. Okay, but we were able to see it on the memory usage. And then what we have done is that we have done a new rollout. It has created a healthy pod. We have enabled HPA, and the HPA has actually deployed 5 pods. And you can see actually that we are having 4 pods. So the HPA is realizing, okay, there is no load. We are using only 7% of our resources. Let me scale down. And it's going to be scaling down back to 1 pod. But now we want to run our AI analysis. So let me just press enter. Now it's going to be running this command that you can see right over here. Scripts analyze incident bedrock, and then the name of the log. The name of the log is this one, what you can see, incident demo 2025. You see incident demo. So what it does now is that it is calling AWS Bedrock. You can see it's terminating 2 other pods. HPA decided that there is no reason for us to have these pods. There is no load on our infrastructure, on our application, and it's terminating pods. And I'm pretty sure it will actually terminate also the other one. So it will be only 1 pod running at the end. Good. Let me just show you what actually happened here, because this is really important. So, let me go a little bit higher. AWS Bedrock. Searching for the analysis file. Bedrock analysis, this one. Okay. So this is the actual payload. This is the actual prompt that we are giving to our Bedrock. You are an expert SRE analyzing a Kubernetes incident. Please analyze the following incidents and the log data provided, and provide a comprehensive incident analysis report. Please provide it in the JSON report. And then what we are doing here is that we are providing all of the logs right over here. This is all that we are sending to Bedrock. So all of those logs from this .log file, we are sending it as a payload to AWS Bedrock, and we are configuring it to be using Claude Sonnet 4 model. Okay. So we are sending this. Then this is the text prompt, just very simply in a nice format. What we are requesting, you are an SRE expert, please provide the output in the following format. You can read it, but it's just some mumbo jumbo, and yada yada yada. This is, you see, these are some of the logs and etc. Focus on the root cause analysis from the logs, understanding the incident timeline. This is the actual Bedrock response right over here. And remember, all of this is being done by this bash script that we are calling. And the bash script that we are calling is this one. We are doing scripts, analyze incident bedrock.sh, and we are giving it the file that we are having locally on our machine. This file must be here locally in /tmp. Okay, so it's taking one parameter, and afterwards it's calling AWS Bedrock Claude Sonnet 4. I will just highlight something because it's really important. Again, the Bedrock is configured in the US region. While all of our infrastructure is in Frankfurt, there is actually no Bedrock in Frankfurt region. So I'm connecting to a North California region that you can see right over here. And if you want, you can be also chatting with the model. You can just select model we want to Anthropic Claude Sonnet 4. And if you want, you can be just using this. You can be using this as a regular ChatGPT. That's not a problem. You can be setting a max length. We could maybe put it a little bit higher, and then you can be using it. This is what we are using under the hood. But we are doing an API call. You must enable Claude Sonnet 4 in model access. It must say access granted, and you cannot do it with AWS CLI. I tried to automate it so I don't have to do it, and you don't have to do it, but you actually have to go here manually in AWS Web Console, and you need to actually make sure that the access is granted. Okay. So we are back here. So we are running this script, analyze incident bedrock.sh. Okay. We can briefly look at the script if you want. This is the Bedrock. This is the actual call that we are doing, and AWS region, because our AWS is the infrastructure is in Frankfurt, but Bedrock is in North California. What I have done, we have to special. Just a second. I had to mention it probably at the beginning. AWS region, US West 1. Okay. Really, really important. This is the prompt that we are going to be using. You are an SRE specialist, analyze this stuff, and we want it to have some specific JSON format, that it gives us the results in a specific format. We don't want just a random chat. We always, when we would be doing something like this, we would ideally want the response in some formatted way. Okay. Max tokens, probably we could increase that, but this would be the call model, Bedrock model, and we are providing it the payload file, which is the argument. Then display the analysis structure. We are doing some mumbo jumbo some JQ commands and stuff like that. If you want to know more about this script, copy, paste it into ChatGPT and tell it to explain it to you in simple terms. Okay. Good. What is the actual response that we got from our AI robot? This is the actual output. Input tokens 5,000. Output tokens 959. I press Alt Z, and this is the output that it actually gave us. What we will do now is that, yeah, it says it like this, but just to make it simple for us, Control A, Control C, Control A, Control C, and we will just put it into Claude 4. Please just rewrite this payload in nicely human readable way. Okay, just so we can look at something nicer. So let's have a look. SRE incident analysis report. Memory leak causing application instability and HPA metrics failure. We have disabled the HPA, but it doesn't know it. Severity medium, approximately 3 minutes, right? That's how long our memory leak was probably running, etc. Affected services, our SRE demo app, then pod autoscaler, and then our metric server. Apparently, memory leak simulation was enabled in the application via API code, causing pod restart and resource instability. This might actually happen in real production, guys, because in the real world scenario, it might be actually an API call from your other pod that does not want your main pod to crash, but it does. Software engineering is very, very complicated, and stuff like this does happen. So in our case, we have called the memory leak endpoint ourselves, but in real world scenario, it could happen because of some reasons, because you are sending payloads between different pods, and your pod is processing the transaction, sending the information to another pod that is then calling some external provider, sending an API to that guy, and getting some payload back, and then processing the data further. Root cause analysis, memory leak simulation was enabled. Contributing factor, metric server API was unavailable. Missing unconfigured metric server. This is all what it thinks only from the logs. It doesn't know that we are running incident demo. It doesn't know that we have done the script. It's just what it got from the log. Okay. Immediate fixes: disable memory leak, and high priority, deploy a new replica set. That's what we have done. In the demo, we have actually started a new deployment, which has shut down the old pod, and it started a new pod. So then we have a new pod that was running, and then we enabled HPA, which actually then scale pods to 5. Okay. Preventive measures: deploy and configure metric server properly. So it's a specs that there might be some RBAC problems. Maybe they are. Who knows? Anyway, short-term action: establish memory usage monitoring and alerting. This is really, really good. Yes, the good practice is that you would be having definitely an alert for the memory. Why the memory is so critical compared to CPU is because if you're having your pod and it's increasing on the CPU metrics, on the CPU usage, what will happen if your pod reaches 100%? What will happen is that your pod is just slow. But if you're increasing your memory, you're having memory leak. The memory is not being released. So it's accumulating 20% utilized, 30% utilized to 100. Kubernetes controller kills the pod, meaning if the end user was actually doing a real transaction, his transaction will be cut. Message lost. I don't know, try again. So then you would need to, if you are shopping somewhere, you would need to probably go press your cart, do a checkout again, and try to do the transaction again. Okay. Lesson learned. HPA cannot function without a working metric server. Okay, yes. So the HPA is actually communicating with the metric server because the metric server is actually giving it the metrics about the pod's utilization. However, in our case, we have actually purposefully disabled the HPA at the beginning. We can rerun the demo in a second, just so you can see it nicely. Recommendation: fix metric server deployment to resolve HPA functionality. Implement some memory usage monitoring, and configure resource quota and limits at namespace level to present resource exhaustion. We will just rerun the demo one more time, just so you know. So again, we are running the scripts incident demo. So pay attention what will happen. We will hide this one. We don't need it. Good. So we are using S3 bucket. We are starting a new lock. Let me show you. Oh, it's not there yet. It's just the old lock, but it will create a new lock. It's running it, checking that the pod is healthy. You see now we are having only one pod. Yes, the pod is healthy. We are calling the endpoint /health. We are having one pod. We are disabling HPA to prevent automatic scale up during the demo. HPA is disabled. Continue. Then we are activating the memory leak. Let me show you Grafana quickly. So we are having our Grafana. Let me show you. So it's 20 megabytes. Now it's 300 megabytes. You saw it jumped from 20 megabytes to 300 megabytes. We will continue in the demo. 1.4 GB. The limit is 2 GB. And then I suspect that it will just say that it goes back to 20 megabytes. 3 megabytes. Yeah. And again, it happened too fast that this is all happening within 30 seconds. So that's why our Grafana dashboard actually does not capture it, but we do capture that it actually dropped to 3 MB, but around here it should be peaking at 1.5 GB. Yes. It locked me out again, gosh. Okay, no problem. Yeah. This is just a script to generate this, but you could be using a kubeconfig file. I guess that could be better than doing what I'm doing now. So maybe do better than me. Yeah, And we are just running the incident diagnosis. Diagnosis completed. We are disabling the memory leak, but the pod, if it's about to reach its limit, it actually returns back to 3 MB because the application is a little bit smart. What we are doing now is that we are restarting deployment. So we are redeploying the pod. Let me show it to you fast. You can see this is what you would do in a real scenario. You would actually start a new deployment of this one. You see, we are having 2 out of 1 paths, and we are terminating the sick pod that was having the incident, and we will be just having 1 running pod, which is the healthy one. Press enter. Looks good. Yes, we are having 1 pod running. It is a healthy one. It's using 18 megabytes. That's fine. And we are enabling HPA, and then we are pushing the logs to S3 bucket. So what you can see, we are pushing the logs to S3 bucket. And what we are doing is that we are now running our AI analysis. It's running this. It's running this command. This is the command that is actually going to be performing the AI analysis. And it's going to be, you can see right over here, this file has been created in our Bedrock analysis. And incident demo was completed. To view AI analysis results, this one. Oh. Yeah. There is this script apparently tennis, but whatever, there is just so much stuff here. Doesn't matter. Good. Lambda, we are not really using it that much. I try to make it work with Lambda, but as I mentioned, Boto3 seems to be having some issues with AWS Bedrock, and I think it's because AWS Bedrock is just so fast moving product that it's changing really, really rapidly. So that's how. So the only way how I was able to actually do a Bedrock API call was by running a bash call from the machine that has AWS CLI configured with the access key and the secret key. Now, for my DevOps guys, we are going to the CI/CD part. So you could see some good stuff here. So what we are doing now is that we are going to GitHub, and this is my repo that you can see right over here. And we click GitHub Actions, and this is our CI/CD. So these two, I had a good idea, but I never finished it, and CBA. So don't look at these two for this project, but these two are fully functional and are something that you would be actually doing in a real scenario. So we will go over it. Let's start with the simple one: build, push, and deploy application, and then we are doing the AI analysis using a CI/CD. So you would not even have, with this one, you would be analyzing the actual incident log just by pressing a button. You don't need all this setup that I have on my machine. You literally just press a button, and that's it. You are getting the analysis of the incident. But let's start with this one. So just I explain it to you. So what happens here is that here are the workflows, by the way. Here are the workflows. This is the one that I am describing now. We are defining some parameters. It's using Ubuntu to run our stuff. It's using the AWS credentials, which are stored in the repository settings on GitHub. The region is configured in env section at the beginning, right over here. And check ECR repository if it exists. If it does not exist, it will actually create it. And it's going to be building the image. So it's going to be running Docker build. This Ubuntu machine or container, I suppose, is actually having Docker install on it. That's why it can be running Docker commands. And it's going to be running it, and it's going to be then pushing it. You're updating kubeconfig with the cluster name and AWS region. And then what we are doing is that we are actually doing a Helm deployment. So it will actually see our cluster, and it's actually going to be doing a Helm deployment. And afterwards, we are verifying the deployment, and we are showing the deployment information. Good. So again, if you don't understand something here, discuss it with ChatGPT, not with me. Or write it something in the comment. Write me a nice comment. Branch main, and we are going to be running it. And just to show you that I'm not bluffing. You can see the port is 5 minutes. Where is my ECR? You know, because someone will be saying, "Oh, it doesn't really do what does it say it should do." That's not a problem, buddy. SRE demo app right over here. And we can see that the last image was 11 p.m. Now we have midnight. So we are clicking here, run workflow. So this is going to be building our incident application, building a Docker image, pushing it to ECR, and redeploying it. Right over here, right over here. Now it's building, tagging, and push image to Amazon ECR. It's building all the layers. It's pushing it. What does it do? Oh, now it's building it. Run npm install to install the dependencies from package.json into the image. Layer already exists, pushed. And you could see it right over here. Where was it? Pushed it to. So it's renaming it. And I guess it already pushed it. Now it's trying to do the deployment. Let us check the F5 for reload. You can see last recorded pull time. So it actually pushed the image right over here. So this is the new version, pushed at 9:36. So we go back, deploy application with Helm. Okay, let us go right over here. Yes, you can see that what happened right over here. Just a second. It is actually running the new pod with the latest image 39 seconds ago, and it's terminating the old pod. And now we just have the new pod running with the new image that we have just built. And the deployment has just changed. So Helm just has upgraded actually the Helm just upgraded the image. And we are running now with the new pod. And what you can see right over here, post job cleanup, You can test the application. You can run incident demo. Yeah, that's fine. Yes, that's what this is the main script for the incident. And some post checkout mambo jumbo. Yes, show deployment info. So we have tag it. Can we see the tag here? Oh, we can just see that it's latest, but we could see the tag right over here, right? Yeah, you see this is the tag. It's tagged by latest, but it's also tagged by this one. Not there, but we can see it right over here. Service URL. Okay, yeah, so it's giving it the URL to the application. And it's actually, because it has AWS CLI, it actually is able to also see the pods in our namespace. Good, so this is the first GitHub action that we have, and now to the good one, to the AI GitHub action that we are having. Analyze S3 with Bedrock. Okay, so the mechanism here is going to be that when we ran the demo, it always creates a log file with the current timestamp, year, date, month, time, and the incident demo itself does, which is this one, incident-demo.sh, does actually push the log file into S3 bucket. Get S3 bucket name, S3 int logging function. Upload logs to S3. So it's this function. And you can see we are having S3, we are having it in incidents, we are then having it in incident ID, and we are going to be actually pushing it in our S3. So these exact files are in our S3 bucket. Let me show it to you. So what we will do now is that I will go to S3, Frankfurt region, and here you can see we are having it right over here, incidents, and we are having exactly the same logs right over here, you see? So we are going to this one and this log right over here. And you could download it, open it, and it's just the same log file with some prints over Kubernetes events and what has happened and stuff like that. Good. So what we are doing now is that, again, incidents, we are going to here, and we are having this log file right over here. What we will do now is that we will be using object URL, this one. This is required as an input parameter for our AI GitHub action flow. And this is the only parameter that it needs. So I am clicking here, copying it. I am going to GitHub, analyze S3 logs with Bedrock, run workflow, and it requires S3 object URL, which is this one. I'm pasting it in, and I run the workflow. And it is going to be running again. We will check the GitHub action and also the documentation for this GitHub action for you guys. So don't worry, just give me a second. So it runs the stuff. Analyze the logs. So It's checking that AWS CLI is done. It makes sure that it injected the AWS credentials. It is making sure that it has access to AWS Bedrock. You can see US West 1 list the foundational list the foundation models. So yes, it connected to Bedrock. We are using the model name Claude Sonnet 4. And here we are extracting the we are getting the log from our S3 bucket, and we are downloading the log file from S3. So you can see we are downloading it. What we are doing afterwards, that we are running, we are taking from the repository, S3 logs script.sh. So we are taking this one. We are renaming it as analyze log.sh, and we are running it. Okay, so basically it's just running this script right over here, bash script. And what this some warning, but okay, whatever. Anyway, what we are doing now is that we are basically sending the payload. We are going to be sending the log to the AWS Bedrock, and this is going to be the output of the Bedrock that you can see right over here. Let me just check it. Artifact download URL right over here. So we can download the artifact, and let me just check it and analyze results. So you have the results in the txt right over here. So what are the immediate fixes? Restart the application pod, ensure that we have a new state, verify the health, and etc. So, and here are the recommendations for the monitoring, for the infrastructure, for the alerting, that we should be checking for HPA. You see, it's giving different alerting recommendation from the other incident. From the other incident, it was saying to be also monitoring on memory. With this one, it's actually thinking that the problem is with HPA, because when we run the incident demo at the beginning, we disable HPA, and it can see it in the log that somehow something went wrong. And then analysis type by Bedrock analysis. And you can see the full Bedrock response in the JSON format right over here. I just opened it in VS Code. Okay, how does it work a little bit? Let's just talk. So all what you need is that you need to make sure that in repository here, again, you need to configure your secrets, these ones. If you don't have it, new repository secrets, and you get it from going into AWS IAM, your user, and make sure that the secrets, the user credentials are there. And all what you need to do is that you're going to be going analyze S3 logs, and again run workflow, and you provide. We want to, for example, now analyze the older one. So I will just go right over here. Here is the log, object URL, copying it, paste it, run workflow, ship it. And it's going to be analyzing the log for us and doing the API call to Bedrock. You might be built a little bit for the API calls, but I am pretty sure it's pretty cheap, maybe like 0.005 cents or something like that. So I don't know, you will need to check the billing on that. I'm not sure. Yes, and then again, it's just processing it and running the script, analyzing the logs, and this is the actual output also right over here. I also print, by the way, the output right over here. Fixed metric server deployment. So now it says again a little bit differently. Yeah, because it's just using AI. We just give it the logs, and the responses might be varying from time to time, right? But the good advantage is that if you can give it a lot of logs, and it would then just analyze it for you. So this is just my POC for that. And this is the full payload, full Bedrock response, and you can download the artifact again right over here. So let's just go right over here. Analyze S3 logs YAML. So this is actual the GitHub action that we are running right over here. Yes, you need to have the input S3 object URL, right? That's the one parameter that you need to have. Then it's running on latest Ubuntu. We are taking the credentials. We are specifying US West 1, not Frankfurt, US West 1, because we want to run Bedrock. Okay. Sudo apt-get update, install JQ curl unzip, some stuff, whatever, checking that AWS CLI is installed. It's running this command. This is a good command because it actually shows you that you are getting the output. It's actually listing the model Claude Sonnet 4, and you could see it in the workflow. Extract S3 and key from URL S3 info. S3 URL. Yes, we are taking it from the inputs. We are taking from the input the S3 object URL. Okay. If it is a problem, if you give it some wrong stuff, it will just give you an error that you did not give me the S3 object URL. We are downloading then the log file, and we are storing it as incident log. Then what we are doing again, we are taking this script right over here, this sh script, and we are calling it analyze doc log.sh, and you need to run shmod +x for the log to be not for the log, for the sh file to be actually executable. And then you run you just run the script, and it is having that incident log there, and then it's going to be analyzing it. We are just doing some JQR mambo jumbo regex to be showing some response ID and some good stuff. Just some regex mambo jumbo, and then we just upload the artifact. Yes. And we are putting there all of the files, and we are keeping the retention days to 7. Yes. Yes, this was just some testing script that I was running, but this is the main one. Test S3 logs script, which is going to be used by this GitHub action workflow. If you want to run it locally, and you would need to have the logs locally in /etc, you would need to run this script, which is called analyze incident bedrock.sh. You are also having some small .md file that I have put there for you guys. Yeah. Works with both local and good. Let me go back to my presentation. So we have gone over everything. Monitoring setup, access Grafana, and we have gone over the AI powered incident analysis. As you can see, you can do it from the local script or by using the S3. Yes. So AI analysis, incident demo logs, local S3, AI analysis, actionable insights. Oh yeah, we will need to clean up, guys. We will need to do some cleaning up. Do not, yes, important reminder, do not leave this infrastructure running. Set up your AWS budget. I have showed it at the beginning. Then it's just some stuff. Doesn't matter. You could be having load balancer issue, whatever. Key takeaways. What we have accomplished, guys. We have provisioned the full infrastructure running Terraform infrastructure as code. And you can see that you can be running deploy.sh as many times as you want. It remembers the infrastructure state because it's using this terraform.tf state file where it's saving the current state of your architecture and infrastructure of your infrastructure. We have done a Kubernetes deployment, how you would do in actually real production using Helm charts. And we have done a comprehensive monitoring and alerting. We have deployed full monitoring stack. You could be just having more pods, more containers, more namespaces, whatever. We are monitoring everything, right? We were then having our incident demo as a real site reliability engineer. I had to include this. And then we also automated building an image, pushing it to ECR, and deploying it with Helm charts. We have automated that. You can just push a button and it's done. And we have also automated the AI incident analysis, but you need an input S3 object URL. Learning opportunities. We are showing you, or I am showing you, the Terraform best practices, real-world deployment patterns, and observability in practice. Feel free to use this project as you want. I don't care. So git clone it, fork it, or whatever. I am going to publish this project as an open source project from me towards the community. All I ask, please maybe give a subscribe, give a like, write me a nice comment, and please follow me on LinkedIn where I'm posting about cloud, DevOps, platform engineering, and etc. Yes, some security consideration. Do not push TF state to your Git, but I have placed it in git ignore, so unless you would specifically go to git ignore and remove what I've written, it will not happen. Alternative usage, you could be using for production. You would actually, in real world, you would be wanting to store the tf state file, this one. So as I mentioned, you would actually place it into S3 bucket, and you would be managing the lock and the LOCK with DynamoDB. And never commit your secrets or an access keys to Git. I think that's quite self-explanatory, but please just don't do it. You need to either use that .env file like here, where you are going to be where you're going to be writing down your credentials or your environmental variables that are sensitive, like your passwords. And in Kubernetes, the passwords are actually going to be stored in secrets. There is a resource called secrets. Good. So this is what we have accomplished. The last thing that we can do, we can just quickly highlight the architecture just for the recap. But what I suggest is that what you should do now is that you should find the part of the video where I'm going over the different architectural flowcharts, and then have a look at it again so you understand. But what you can see here, very briefly, we have our GitHub repo, we have our secrets, and the workflows here. This is the build and push workflow that is actually going to be running the Docker build, pushing the image to our ECR registry, and then we are going to be deploying it using Helm charts to application pods. So we are going to be doing a deployment here. Then we are having another GitHub action that is actually going to be taking the log as a parameter from S3 bucket. Then it's going to be doing an API call to AWS Bedrock. AWS Bedrock. And then it's going to give you the analysis as an artifact, or actually even print it into the terminal of the, or into the console output of the GitHub workflow. Local machine, in order to run the Terraform, you need to actually run it locally. Terraform apply. We are building also, this is all run by deploy.sh. So you just run deploy.sh and it's going to be running a Terraform apply, which is going to provision all of this infrastructure right over here. And it's going to be also running the local Docker build. Okay. And the Terraform apply is also going to be applying all of the resources, and then we are doing the Helm upgrade, the Helm deployments right over here. We are deploying in our Kubernetes, in the Kubernetes itself. We are going to be deploying all of these resources right over here. Yes. So what I will suggest, what you will do, is that have a deeper look at the architecture flowcharts right over here, Control-Shift-M, and just go over them. Try to understand what has been actually going on all this time. CI/CD pipelines and everything. Now all of this should make sense to you. If it does not, please rewatch the video again. It might click you later. If you don't understand some stuff, anything, if you don't understand anything, please just Google it, ChatGPT, Gemini, ask someone, write me a comment, and I might reply. And yeah, so that is the architectural flowchart. Good. So please go over them. Here is the integration guide for the Bedrock. How I have actually implemented the Bedrock, and yeah, feel free to go over it. Up to you guys. That's fine. There is one script right over here, curl.sh, and this is just a very tiny AWS Bedrock call that I have done just to test the POC that the Bedrock actually does work. And let me run it for you guys. Bedrock curl works. So the prompt that we are asking is actually explain Kubernetes like IAM5. And it has then created the response in response.json, alt-z. And imagine you have a big toy box full of different toys. Okay, these are like computer programs, and you want to play with them in your playroom. Kubernetes is like a super helpful robot friend. Organizes your toys and yada yada yada. So this is just a Bedrock call, really bare bones, without including it in any of the heavier scripting. Okay. I will summarize the flow for you guys. What you actually need to do. What you will need to do. Let me just super simple guide.txt. Guys, what you will need to do. Actually, we can call it maybe not txt. That's fine. What you will need to do is that have prerequisites. How do you write prerequisites? That's a good question. These ones, the dependencies. Have this have prerequisites, have dependencies installed. This stuff. And of course, you would need to type AWS configure and make sure that your credentials are working and it's connected to the cluster. Then what you will need to do is that you will need to run scripts deploy.sh. What this will do is that it will build infrastructure with Terraform, build Docker image, and push it to PCR, deploy the build image, into default namespace in EKS, deploy monitoring namespace in EKS. So this is what the deploy.sh script does. Okay. Then what you would do is that you would be going into scripts and you would be running incident-demo.sh. What this will do is that it will activate memory leak on your SRE demo app in default namespace. And what I suggest, monitor it using Grafana. It will create a log file in /tmp/incident logs. I think that's the correct one. Yes. Here. Or this. And then it uses analyze bedrock.sh. It uses this guy. To actually send the log to Bedrock, which uses Claude 4 in US West 1 region. Okay. You will see the output. The output is right over here. You'll see the output in folder, this one, Bedrock analysis. And the output, yeah, it's Bedrock response. That's the output. Good. So you will run that. Then, most important, GitHub workflows are this one and this one. So what this one does, takes log input requires object URL from S3 as input, and then it sends it to AWS Bedrock Claude 4 for AI analysis, prints the results in console output, and stores it as an artifact. What this one does, this GitHub action job is build your application placed in app folder, uses Ubuntu base. Yeah, the GitHub action uses Ubuntu base, builds the container, builds the image by installing dependencies package.json. Server.js is the main application that is actually going to be running. And then it deploys this application using Helm in default namespace in our EKS. Okay. So these are the important ones. And now we are done. Remember, feel free to brainstorm anything with some AI bot or with Cursor, Claude 4, but you might need to pay for the subscription for that, because I think the free plan gives you only like 80 cents worth of credit or something like that. Super simple. Good. Then destruction, the complete demolition. What we do now is that we will now we ran scripts teardown.sh. This will run Terraform, destroy, was it auto approve, something like that, and destroy all of our infrastructure so we don't pay high bill. And then you run another script for some simple verification. Teardown verify.sh. So you run this one. Simple script to check that you have no EC2 running, no EKS, no, I guess VPC, I don't remember what I put there, and other resources. Just a sanity check. But feel free to run teardown.sh 2-3 times if you want. You can't hurt anything. Okay. Actually, I think at the end of the teardown, after it's done, it will actually even clean up the tf state file. This one, let me just then demo what has been changed here. Anyway, discard this one. I will just clean up these ones. We don't really need them. They are just the payloads that will be generated. I'll just create it, and this is the response of explain to me Kubernetes Lacan file prompt. This is the super simple guide, and then what you should do. Good files to check. This one .md, .md, and definitely the architectural flowcharts. This one, and any MD that you are interested in. I was creating a lot of them, but there is a lot of different angles and a lot of different stuff and tools that we are actually using here. And for the flowcharts, I'm using something called Mermaid, because this is the actual code of the flowchart that you are seeing in the architectural flowcharts right over here. This is the actual code that is creating that flowchart. And then when I press Ctrl-Shift-V, it will visualize it into a flowchart. So Bedrock. Bedrock prompt. We can also this one. Respond. Final commit during recording. And we commit and push. Good. So, as I mentioned in my video, in the document, what we need to do now is that we need to tear it down. So we are now deleting all of our infrastructure. Meanwhile, while it's running, we can actually check what is doing it. Teardown.sh. ECR repository deleted. EBS CSI cleaning up the bucket. So you can see, this is the teardown script. A lot of functions. Remove helm release, etc. Starting the SRE demo teardown. So it's running cleanup ECR, cleanup EBCS CSI driver. This is needed in Kubernetes for our deployments, for our monitoring. Cleanup S3 bucket, run Terraform destroy, auto approve to tear down our infrastructure. Clean up local files. This will actually clean up the TF state file, so we don't have it. Show cleanup summary and print the stuff. Okay. Demo. Oh wait, it's actually also the logs are still there. Guys, it got stuck here in this end section. I had to press Ctrl C, but otherwise just rerun the script. So it was stuck in, I think, when it was trying to delete the different versions of the objects in S3 bucket, somehow it got stuck. So just I pressed Ctrl C, and then now it's running the Terraform destroy, where it's deleting all of the resources. So deleting the security group for the node, and etc. So all of the good stuff. So we are not paying a big bill, of course. Destroying the public subnet, destroying the internet gateway, and all of the resources. Still destroying. So what is happening here is that the node group, which was controlling our EC2 instances, was deleted, and now it's actually deleting our EKS cluster right over here. And you can see it takes a while. For the node group, it was actually deleting it for 8 minutes, and for the EKS cluster, it was deleting it 2 minutes 40 seconds, and then it's deleting some VPC specific ones and some other resources. Okay, destroy complete. Resources 65 were destroyed. We have removed the Terraform state file, Terraform log file, and Terraform cache was also removed. Cleanup was ready. We have removed the following resources, so all of it. Good. What we will do now is that we will just, or what I suggest, what you will do, Control C. My script has failed. What you suggest, what you will do also yourself, is that you will just rerun it. And it will be really fast this time because there is nothing. EKS cluster was not found. You can see EKS cluster not found, not found, not found, not found. Nothing is there. Good. And what you can do also afterwards, what I also suggest that you will run scripts teardown verify. Okay. And this is just another layer of checking. No EKS, no ECR, no VPC, no load balancer, no security groups for the project one, and stuff like that. Success, everything, your access, AWS account is clean. And you should also, of course, we trust Terraform, but you should also verify. So what you will do now is that we will go EC2, ECR, EKS, VPC, S3, and we will see that there is nothing here. EC2, oh, EC2, oh, there should not be anything. Okay, EC2, you can see that the instances are already terminated, so that's fine. ECR, we are not having anything there, so no images there. EKS, Kubernetes service, we are not having anything here. And the VPC, we are not having any NatGate. This is probably from an older project, that's why it's still there. But we are not having our VPC, we are not having our route tables, and we are not having any of the subnets. Let me just check this one. Okay, it's from our project, but it's deleted. It just still shows a little bit there. And our S3 bucket is very, very clean. Nothing there. Good. So that is everything for this project and for this video. Thank you very much for watching. If you made it to this point, I really appreciate you. You're the real one. I have put a lot of work into this project, so therefore I would really appreciate if you can give a like on this video, subscribe to my channel, and follow me on LinkedIn. You can find the URL below. I will also try to put below of course I will put the URL to the GitHub repository. Feel free to clone it and try it yourself. This is sort of a platform, a learning platform for DevOps, SREs, cloud engineers, and platform engineers to test out the waters. This is really, really super advanced project in my eyes, and I am giving you a lot of know-how how the stuff actually does run in the real productions, serving millions of users. So hope you appreciate it, and hope you like it. So thank you very much. Take care and bye-bye. And it's 1 a.m. That's great. See ya.